This conference will now be recorded.
Okay. Good morning, everyone. So I'm Srinivas. I'm the founder of the institute. Today we'll be starting off with the demo session for VLSI front-end domain training. In our institute, I mean, whatever courses we have, for that we offer two demo sessions. I mean, all courses are categorized into two categories. One is the front-end domain courses. One is the other is the back-end domain courses. So today will be the demo session for front-end domain courses, and tomorrow we'll be having demo session for back-end domain courses. Um, so first, let me just give you a brief about what is that we are going to discuss as part of this demo session. So we'll first start off with understanding what are all courses starting today. I mean, I mean, some of you might have enrolled for design verification course, some might have enrolled for DFT course, or various other courses which are starting today. Then we'll just briefly talk about the institute. We'll then get into a little bit of technical aspects, where we'll start off with first understanding basics of some electronic system. Idea is to understand what is VLSI, what is embedded system, just to understand the top level perspective. Then we'll go into understanding the VLSI design flow as such. I mean, what exactly is VLSI design flow, and what are the two major aspects in that, what is front end domain and what is back end domain. Then we'll talk about in VLSI domain what are the different job roles are there. Like if you say software, there are two or three job roles are there. One is the developer, one is the test engineer, right? So here it's not as simple as that. You don't have two roles, there are many roles are there. I mean, if you go to any company, right, there could be 15 different job roles could be there. Someone could be a design engineer, someone could be a verification engineer, synthesis engineer, physical design engineer. So we'll try to briefly understand what is the difference between these job roles. What is the purpose is to ensure that you have the complete details before you. Those attending online, can you hear me?
Yeah, yes, sir.
Okay, fine. So idea is to give you a brief about what different job roles, and so that you can make a better decision, informed decision, which one to take. Even otherwise, as in the institute, we have a flexibility where up to 2 months you can change the domain. Let's say today you took design verification, you will go through the design verification related topics for 2 months, where you will go through some Verilog programming related training also. After that, if you feel that you're not able, I mean you don't feel that it's right course for you, we'll always give you option to switch to other domain. I mean, in that whole process, you're not going to miss anything. I mean, you when you rejoin into some other batch, you join into a next batch, following batch. Next, we'll also discuss about what is the skill set required. Okay, so it doesn't mean that we expect you to come with specific input. I mean, prerequisites like you should know Verilog, you should be very good with digital. That is not our expectation. We will be teaching everything from the basics. It is just that what is the skill set. Let's say before you get into a job, what is that companies expects you to know. Let's say you are into front end domain, what would be the skill set that you should be having. If you are into back end domain, what should be the skill set you should be having. That will be discussed. And we'll also discuss about how to choose the right domain, and some little base some brief about institute facilities, and how do you prepare for the job, and why choose a career in VLSI, and we'll also talk about placements, and then I'll take up any questions you may have. First, let's start with okay. I mean, I have already talked about myself, right? I'm the founder of the institute. I have worked in the industry since 2005. till 2019, and in between around 2012 we had started this institute. So since then it's been 14th 13th or 14th year we are running the institute. Let's briefly talk about what are the courses that we are starting today. uh, so one thing we are starting today is the RTL design and functional verification course. In that we'll be doing it is the same as when we say this RTL design and functional verification course. It is exactly same as front end training for freshers, design verification course, functional verification training for freshers, or ASIC verification. All these five are referring to the same course. Someone asks me I want design verification course, someone will ask me I want front end domain course. Both are same. Then we also have a course starting for experienced engineers. Many times what happens, people who are working in the industry don't get exposure to everything. They will only work on part of the project flow. So here idea would be to give them exposure to the that entire flow, okay, and do a deep dive into each of these topics. Then we also have course starting for Verilog for design and verification, System Verilog for functional verification. As you are aware, Verilog and System Verilog are two languages which are used in VLSI for design and verification purpose. So these are actually part of the this course major category. But then people who are pursuing their BTech and bachelors and masters will not have time, 8 months time, 9 months time to pursue a full-time course. So we are giving them flexibility to do these courses separately if they want to do. Okay, they can do in live training as well. Let's say summer break, you have 2 months time, you can do one of these courses. Other than that, we are also starting course on FPGA design and verification, then RTL design and integration. Okay, as we discuss further, as we go further, you will understand all the things I'm talking about. What exactly do we mean by RTL design? What do we mean by RTL integration? Everything you'll get the idea. Then today we are also starting a course on DFT. Right. So only today's session is common. I mean, as you go forward, everything will get run as a separate batches. And demo session, as you know, is from 9:30 to 12:30 p.m. And we'll also have DFT demo session in the post lunch. Maybe it could be today, or in some case it could be tomorrow. In case you are looking for DFT demo session, our admin will inform you the schedule for that session. And if some of you are looking for FPGA course, let us know. There will be a separate demo session for that. And even for RTL integration course, there will be a demo session. You please let us know. Please connect with our admin. He will let you know the schedule for that. So this is a brief about different courses we are starting today. Uh, First, let's start off with understanding of electronic system. I'll keep it brief so that we'll go more deep. More we can spend more time into VLSI related topics. What is the agenda for today? Okay, but before that, I feel it is important for each of us to know what exactly is an electronic system. Where does VLSI come into the picture? Where does embedded system come into the picture? And how VLSI and embedded systems are related to the other layers. If you take any electronic system, let's take a mobile phone or a laptop, anything, it is not just the hardware alone. Okay, there are a lot of other things that makes the mobile phone work. If you take a plain hardware, it won't work. Tell me what else is going into the mobile phone because of which you are able to use it. There are, other than the hardware, there are other things that are going into this phone because of which we are able to use the phone. What do you think are the other things that makes it work? OS, operating system. What else? Okay. Applications are there, like even WhatsApp, Google Maps. There are many things because of which you are able to use. Okay, though applications are not essential, but OS is essential. What else do you think goes into the mobile? there is an important aspect called as embedded systems. That is the drivers. Embedded system sits between hardware and the operating system. So we can essentially think of an electronic system to have four layers. The first layer is the hardware, the one you see. Okay. Above hardware, you have got embedded systems. That is, you can call as embedded systems, the firmware, drivers. This is the second layer. On top of these drivers or firmware, you have got operating system. On top of operating system, what do you do generally? Once you get the phone, what else do you do on top of phone? Install applications, right? Different apps you download and install. This is the this is how most of the complex electronic systems will be. I mean, there could be systems where you may not have embedded systems at all. I mean, OS itself might do all the work, or embedded system might do all the work. But if you talk about a generic electronic system, it has got four layers. What is at the bottommost? Hardware. What is above that? Embedded system. You can call it as firmware, you can call it as drivers. Then on top of firmware, what do you have? Operating system. On top of operating system, you have different applications. As a VLSI engineer, what do you think is our role? Which layer do we work at? We are responsible for development of the hardware. Our VLSI engineers responsibility is to develop the hardware. Then who develops firmware and drivers? Embedded system engineer. There will be a separate person called as embedded system engineer. Then who develops operating system? The software engineer, right? Then for developing apps, it could be apps developer or it could be a software engineer, right? All of them, right? It's a generic thing. As a VLSI engineer, you're only concerned about this layer, and what else do you think we should be little bit having idea about? Other than hardware, as a VLS engineer, let's say I'm a VLS engineer. Other than knowing hardware, what other information, what other layer should I be little bit familiar with? Embedded system, right? Because it is the immediate layer to me, so I should be little bit familiar with how embedded system interface with the hardware. Do I worry about which operating system will come into my phone? Let's say I am working into a team which develops the mobile phone chip. Okay, I am responsible for development of the hardware. So I don't bother about which operating system will be installed, which applications will be installed, whether WhatsApp will be installed, all that. My thing will be how hardware should be developed, how embedded system should work. To understand this different layers, let's take a simple analogy. Okay, bus is the best example. Bus with passengers. So bus is like the hardware. Bus is the hardware. Then who controls the bus? Driver. That's why the term driver. See, we use the term driver in the electronic system. You might have heard USB driver need to be installed, SD card drivers need to be installed. Right? You would have heard, right? Why the term driver is coming? Same thing. Like the way in real life the driver controls the bus, means the driver controls the hardware. Even in electronic system, the driver controls the hardware, how hardware will behave, when it will turn on, when it will turn off, when it will do the transfers, when it will stop the transfers. That entire thing will be controlled by embedded system. Now let's take again the example of a bus. If there is no driver, can bus do anything itself? Forget that automatic thing. Okay, the traditional things, Without a driver, can bus move itself? Nothing, right? So the same is the reality with the mobile hardware also. If there is no driver, if there are no drivers, if there is no embedded system layer, firmware layer, hardware cannot do anything itself. Everything that happens in hardware has to be controlled through embedded system. Everything, even mobile phone turning on, turning off, somewhere it is related to embedded system. Then on top of so who where how does embedded system gets instructions from? OS. Then OS in turn has applications which control it. In summary, again going back to our analogy, what is the analogy we took? Bus example. Bus has four elements in it. One is the bus, driver, conductor, passengers. How many are there? Bus, driver, conductor, passengers. So bus is similar to hardware. Driver similar to firmware. Even we can even call them as drivers. Then conductor is similar to operating system. Then passenger similar to apps. So where does it get more complex? Where does electronic system get more complex? In case of bus, there are only one thing to control. In case of bus, there is only one thing to control. What is only one thing? The bus is the only thing to control. In case of hardware, my firmware has to control many things actually. Firmware has to control USB behavior, SD card behavior. So everything, lot of things that goes into the phone, it has to control. So that is where it's not driver, it is plural. Drivers. Do you understand why we are using the term drivers? Because it's not just one thing, one hardware we are controlling, one piece we are controlling. Multiple things need to be controlled. That's why we are calling it as the drivers. Whereas in case of bus, do you have multiple drivers controlling the bus? No, there is only one thing. So hence it's only one driver. Whereas in hardware, lot of things to be controlled. For controlling each thing, we have one driver. To control, let's say, Bluetooth. To control Bluetooth behavior, we have what? Bluetooth driver. Let's say to control USB behavior, USB driver. So for every peripheral or every hardware, that every part of the hardware you have, there will be a driver. Now let's understand what exactly goes into a driver. First, let's ask a question. Again, I'm not talking about the bus example here. Coming back to electronic systems. What goes into a driver? So is it a code, or is it a piece of hardware? What exactly do you think is a driver? What do you think is a driver? Is it a code, or is it some kind of physical piece, physical element? Not both. Driver is always a code. Anything physical element is always a hardware. Anytime you are talking about anything physically, you can feel. Let's say I'm feeling this phone. I'm able to touch the phone and feel the phone. This will always be hardware. If you open, there is a camera. Camera is also a hardware. Let's say there is a touch sensor. Is it a driver? No, it is a hardware. Anything that you can feel through physically is always a hardware. Is operating system a code or is it a hardware? Is it some piece of physical element? It's a code. Applications, you are developing WhatsApp, you develop some piece of element. No, right? It's code you are developing. So anything other than the hardware, everything else is a some level of code. Now are you clear? So when we say some embedded system engineer is developing some driver code, so he is basically developing a piece of code. What that code is going to do? That code is going to control the hardware behavior. Now he has to ask, what is that I want to control? Do I want to control USB? So he has to develop what? USB driver. If I have to develop a Bluetooth driver. SSD, then I have to develop SSD driver. Simple. For everything, you add a driver. Okay. Can one person develop everything? No. That's why companies will have many people working on independent things. I don't want one person to develop everything. I'll have one person develop related to USB related code. Okay, PCI related thing, SSD related thing. Okay, that's one thing. Okay. Now let's further go a little deep into driver code. What exactly goes into a driver? Why we are discussing? I mean, you may be thinking we are talking about VLSI. Why we are going into embedded systems? Idea is to get the top level picture, because I don't want your knowledge to be only limited to just verification. Okay, rather you should have a brief idea about what is VLSI, above VLSI what is there, so that you will have a better idea. Then probably at the end of today's session, you will have an idea why processor is so important. See, whenever you buy a mobile phone, what is the first thing you ask about? What is the processor specification, right? What is the model, which company, what is the frequency? Everything you check, right? Because between hardware and firmware, I'll just call the term firmware. You can use the same term for drivers, embedded system, everything. So for simply keeping it simple, I'll use the term firmware. So when firmware wants to control the hardware, what it does is it's a piece of instructions. It is present in which language? Tell me, can someone tell me which? Whatever I'm showing, the code I'm showing, this one, what do you think is this language is? Machine language. Why it should be machine language? Only that is the only language that my processor understands. If I tell to my mobile phone, do this, it won't do, because it won't understand English. In my mobile phone, whatever hardware is there, it will not understand English. It won't even understand Verilog also. Then you may say, why are we learning Verilog? I'll tell you that also. Okay, for now, during your BTech you would have studied 8085, 8086 or ARM architecture. Some one of them you would have touched upon, right? So in that you would have studied add, sub, multiple assembly language instructions. Okay, when you compile, you get something called as hexacode, called as opcodes. Okay. In summary, add R0, R0, R1. Tell me, what do you think I'm doing here? I'm adding R0, R1 and storing result into R0. What is R0 and R1? These are the registers which are present in my processor. Add is a instruction. R0 and R1 are the two general purpose registers that are present in my hardware, means in my processor. Like this I can do multiple things: sub, multiply, okay, branch. There are almost 50-60 instructions will be there. So finally what happens, let's say I write just a typical code R2 minus R2 R3, few things I do, let's say R0 comma R5. I just wrote like this. Okay, you this code is called as assembly code. This is called as assembly language. When you do the conversion of this, okay, there will be something called as compile, linker, and assembler and linker. So it will convert into something called as op code, operation code. Op means what? Operation code. This code, okay, some app dot x. Originally this is how it was. Long piece of code. This hex code actually will be stored as so in summary, this line is this code. Now you may say, how did you come up with these numbers? I just randomly wrote. But in processor compilers, there will be a conversion logic will be there. So by looking at this code, my processor will understand that I have to add R0 and R1, store the result into R0. By looking at the second one, by looking at the second opcode, this is called as what? Hexadecimal code. Are you familiar with hexadecimal radix format? Okay, one thing you see is how many bits? 4 bits. One hexadecimal, whatever character you see here is 4 bits. So totally how many bits is it? Each one is 32 bits. So whenever my processor gets this opcode, it decodes that opcode and understands that I have to do a subtraction operation. Next, when it gets this code, it understands that I have to do a multiplication operation. So as an embedded system engineer, when I develop an application, I develop application in embedded C language. Using which language do I develop my application? Embedded C language, or you can call C language. I won't even develop in this format because it's more difficult to do. Doing at assembly level is more difficult. I would rather do in what? Embedded C language. There will be something called as compilers will be there. ARM compiler, x86 compiler, specific to the processor you are using, there will be compilers. When you do that compiler, let's say I wrote this code for I equal to 0, I less than 10, I equal to I plus 1, sum equal to sum plus I. Something I am doing. What do you think I am doing here? I'm running a loop from 0 to 10. I'm adding all the numbers and storing it into sum. This code, when you convert into assembly code, it will come something like this, assume. Finally, during the linking, so there will be something called as linker will be there. What that will do is, it will further convert this into this format. So whatever applications we are talking about, let's say WhatsApp application or even any application, it will all be present in this kind of format actually, in hexadecimal codes. Bigger the application, you will need more such things, right? Bigger will be the image file. That whatever you download, sometimes the files will be 1 MB only. Sometimes files could be 500 MB also. Okay. So that means what? 500 MB file means what? More such instructions will be present. More the number of things, more will be the size, right? Let me again brief about what is that we are discussing about in case some of you got confused. We are talking about what goes into a driver. Okay. So as a embedded system engineer, okay, embedded C language is used to implement the drivers. These drivers control hardware behavior. What does these drivers do? They control the hardware behavior. Now, how do we develop embedded system? Let's not get into it because that's out of our scope. Whatever embedded C language code is converted to assembly code by using compilers. There will be a compilers which will convert it into assembly code. Okay, or you can, okay, then there will be some multiple stages. This assembly code is further converted to opcodes, that is hexadecimal format. When we run an application, when we run an application, when an application or a driver needs to be run, it's that code, that hexadecimal code, that is opcodes, gets loaded into a memory. Let me take you there itself directly, the diagram is something like this. See, I have a memory, DDR or flash memory, this one. Here, those opcodes are loaded. You know, right, in your memory you can store all the information, so that is loaded here. Whenever I start the processor, it fetches those instructions. Are you familiar with that sequence? Fetch, decode, next what? Execute. It fetches the instruction. Decoding means what do you think decoding means? Understanding the intent. See, decoding means what? This means this instruction, this means this instruction. That is called as what? Decode. Fetching means what is meant by fetching? When we say fetch, I am fetching a book means what? I'm fetching a book from library. Somewhere on the main road library is there. I'm fetching a book from library. What does it mean? I go to the library and bring the book. So here fetching means processor is sitting here, code is present somewhere else. So it is asking it to get the code and getting the code. So did you understood what is meant by fetching? So what does it fetch? It fetches the opcode, that is hexadecimal code. In which line number do you see hexadecimal code in our file? In which line number? Line number 13 to 15. Now is it only 3 lines? No, that's why I put dots, means lot of other code is there. Once this is fetched, what is the next step? Decode. What is decoding means? Understanding what is it actually. Then execute means what? Like I will ask you, what is 15 plus 7? 12. 27. The way you are doing calculation, even hardware has a ALU. What is ALU? Arithmetic logic unit to do all these calculations. And it will do those calculations like what is the result? 27. The way somewhere in your brain you will store, right? After 10 minutes, if I ask you what is the result, you will tell me 27 is the result. Same way, like you have few things in brain to store the result, processor also has a mechanism to store the results for time. Those are called as registers. What does registers do? They store the value while the calculations are happening. So as part of that, finally understand that when you execute this series of instructions, it ends up controlling the hardware behavior. It may involve processor going and programming some register here, changing some values here, essentially changing this behavior. Let me again explain this. What is this one? DDR memory or flash. On top of this, what do you have? Operating system. On top of operating system, what do you have? Apps. Okay. Now, what did I do? I went to my laptop. I did right click, send to some pen drive. You know, right? When you connect to a pen drive, it will say send to drive. Are we doing this whole thing at operating system level, or where? Somewhere at operating system level only, right? We went to the operating system, then right click, send to. So in that case, what happens is an instruction goes to the processor to execute that piece of code. Then what it will do? It fetches those instructions one by one. It decodes, execute. As part of that execution, it will go and do some transactions to the USB controller, which in turn does transfer to my pen drive. Okay. For now, this much is good to know. I mean, let's not go too much deep. So, idea is to what? Understand what is VLSI, what is embedded systems. So, are you all clear with this thing? If you want me to repeat, I can repeat things. 1 minute, just give a minute. Okay. So, those attending online, please be in mute. So, just to briefly summarize, we were let's quickly revise the whole thing so that we were discussing about electronic systems. So, typically, electronic system consists of four layers. What are the four layers? Hardware, firmware, OS. What is the responsibility of VLSI engineer? Only develop the hardware. VLSI engineer responsible for developing hardware. Embedded system engineer responsible for developing firmware or drivers. You can call many. There could be many things. Okay. And the OS and other things, software engineer or app developer. Then we were discussing how firmware talks to hardware. Okay. There is no language like English where firmware will give some English instructions to hardware. How does it happen? It happens through machine language, machine code. Machine code is something like some kind of code which when I give it to the when processor gets that code. So when processor gets that code, for example, whenever I'm just giving one example, okay, in real life it will be millions of such things. How many? Millions. That is how your applications are so big. Let's say when you are playing some gaming application, what will be the size of gaming applications? Gigabytes, right? Gigabytes means you can imagine. So this is how many bytes? 4 bytes. Gigabytes means what? How many such things should be there to make it gigabytes? A lot, right? So when processor gets that code called as opcode, it decodes it and executes. As part of it, as part of it, it controls the registers that are present in the USB controller. As part of it, my processor goes and controls. I'll give you a simple example for that. You're all familiar with washing machine, you would have used, right? How do you use washing machine? Whenever you want to use, you should know what is the mode you want it to work in. Do you want to work it in 1 hour mode, 1.5 hour mode, or quick wash mode like 20 minutes mode? There are different modes, right, which you control through knob. There also you're actually doing same thing. You're using something to control that hardware behavior. You're changing some register values. There are some registers which are present in washing machine that you are changing those values to change its behavior, how it is going to behave. So here also essentially the same thing happening. What is happening? Processor goes and changes the registers that are present in the USB controller through which its behavior will change. When it will change, when it is going to transfer, when it is going to get, so various things it will change. You got some idea, right? we have understood all this example, right? What is hardware, what is firmware, what is operating system, what is applications, and what goes into a driver, everything. Okay. So as a VLS engineer, what should you know? You should be little bit familiar with how you should be very comfortable with hardware. You should have some idea about embedded system engineer, basics about it. So any questions till this point? Again, I am telling, you won't be doing anything related to embedded systems in this whole course. Even when you go to job, let's say tomorrow you join Qualcomm, Google, Intel, any company, as a VLSI engineer, you are not going to develop this thing. You will not be responsible for developing of that app codes or embedded system anything. Then why are we learning? Just that you should have an idea, how does embedded system control my hardware. Let's take that bus example. If I'm developing a bus, let's say I'm a company, I'm a team who is responsible for manufacturing, I mean the manufacturing of the bus. Okay, what happens if I keep brake in the front of the bus, accelerator in the end of the bus? Is it possible at having a design where accelerate brakes in the front of the bus, accelerator in the end of the bus? Not possible, right? Why is it a wrong design? It's a completely wrong design, right? Why? It is not convenient for driver to use. For putting a brake, he has to go here. Again, for putting accelerator, he has to run back. So if I develop such a thing, it will be a false design, right? Wrong design. So I have to develop my hardware such that it is easy for embedded system engineer to work with it. I should develop my hardware like I should develop my bus such a way that the driver should easily be able to use it. If I make it more complicated, they won't use it properly. So the same thing applies to electronic systems also. As a VLSI engineer, when I am developing my hardware, if I keep my hardware efficient, embedded system engineer can do his job better. If I make it very bad, this is a bad example, right? Where brakes are here, clutch, accelerator is here. It's a very bad design. Then he won't be able to do it, use it properly. That's why you should know how embedded system works so that you will develop a better hardware. Understood, right? You are not learning embedded system because you are going to do some embedded system work. You are learning because you should know how they are going to control your, how they are going to talk to you, how they are going to use the hardware. That's why you are learning a little bit about those things. So with this, we are done with understanding of electronic system layers. We will not go into embedded system again. Okay, this is just a brief introduction. As a student, for each of you, my suggestion would be that you should develop passion. Let's say today we talked about embedded system little bit. Some of these things might be new to you, right? Might be new to you. If you're already familiar, also good, no problem. You should have that passion where you should go develop a passion in a subject, where you should go and just do Google search how embedded system works, how the drivers are developed. That passion you should develop. Your knowledge should not be limited to only what is taught in the classroom. It is not just for today's session, it is for everyday session, where you should develop that passion that I should become expert in the subject. Okay. That everyone tells, every teacher will tell the same thing, I tell the same thing. Because that's the only way you can learn and you can grow in your career. So please develop that passion where you explore more than what has been taught by the trainer. Okay, there are hundreds of resources available right now with the all this AI. You just click, it will give you the detailed answer for everything. Only thing you need is what? Willingness to learn, willingness to learn, willingness to understand. So that is what you should develop. Okay. Now let's come back to the next topic. So we'll do this topic and then go for a break after this. So now let's understand little more into VLSI. What does VLSI stand for? Very large scale integration. We already discussed that VLSI is about development of hardware. Let's take a simple analogy. Something we see in day to day life, house construction. A house can be constructed in two ways. House can be constructed in two ways. One is you start everything from scratch. House can be constructed in how many ways? Majorly two ways. Okay. Uh, in one style, you do everything from scratch. Like you put the foundation, okay, then you build the walls, pillars, anything, right? You might have seen, right? I don't want to get into the construction topics here. What is the second way you can do house construction? You buy the existing models. Let's say you buy some one kitchen model, kitchen unit. You buy one bedroom unit. You buy one hall unit. Just put together everything. Or already some houses are there. Some prefabricated houses are there. Just get it, keep it, and update it for your requirements. Which one typically we do most of the times? First one, right? Do we do first one or second one? First one. We always start from our own requirement. Tell me, why do you think we do that? See, second one also looks good, right? Second one also looks good because the house is already available. Some structure is already there. You just get that structure. You change it as per your requirement. Then you have a house. So we go with first one where you start everything from scratch and you develop. We'll come to that point. Why do we do that one? Probably whatever we are going to talk in VLSI design styles, that will answer your question. That will answer this part of the question. Even in VLSI, there are two ways in which, majorly two ways, okay, in which chips can be manufactured. The whole design process can be done. One is called as ASIC. One is called as FPGA. How many styles are there? ASIC and FPGA. ASIC stands for Application Specific Integrated Circuit. FPGA stands for Field Programmable Gate Array. ASIC is similar to constructing everything from scratch. The way you put foundation, then you put the pillars, everything, right? That is ASIC. FPGA will be more similar to buying a existing structure, then change it as per your requirements. That will be the similar. Okay, I'm not telling same because can I compare chip with a house exactly? All right, they are two different things. We are just taking analogy. We are taking analogy because you can easily understand house construction, right? If I tell you you're developing everything from scratch, means you can easily correlate, your mind can easily frame that. Okay, so in similar manner, in VLSI, how many styles are there for designing purpose? Two styles are there. One is what? ASIC. What is the second one? FPG. In house example, which one did we prefer, the first one or second one? First one. Same thing with VLSI also. Many companies prefer ASIC. Okay. First, let's understand what is the primary reason why you went for from scratch.
Will be there for the quality.
Quality will be there. Okay. Second, flexibility. You can customize for your requirements. You can, like the way you want to build with the bricks, or you want to build with cement bricks, or whatever, right? What kind of wood to use, everything you have complete flexibility. Second is what you can customize your design as per your requirements. You can plan everything as per your requirement. Whereas if you go for some prefabricated structure, let's say some house is prefabricated, you're buying it and just customizing it for your requirement, you won't have a lot of flexibility, because you are already limited by someone has already provided, you have to just remodel it. Which one do you prefer? First one. Okay, so like that, lot of companies in VLSI also prefers ASIC style, but then there are few companies who does FPGA also. So now let us understand what exactly is ASIC, what is FPGA. Okay, uh, why should you go for ASIC, why should you go for FPGA? I'm not telling don't take FPGA, you should seriously consider FPGA also, because there is very less competition in FPGA. I'm telling again, remember this statement, there is very less competition in FPGA. Many times you will stand a very good chance of getting a job in FPGA compared to ASIC. If you do a FPGA course, your chance of getting a job is better than ASIC, because very few people are available. I mean, not many people undergo training in FPGA. So that's why we are talking about this thing. Otherwise, what I would have done, I would have directly started with what is RTL design, what is RTL verification. I want this session where I introduce you to two terms, ASIC and FPGA. I also want you to seriously consider FPGA domain. Okay, so let's understand. Okay, that house example is only for analogy. Okay, don't literally take prefabricated structure anything. There are some similarities. Okay, let's now go into this VLSI design styles. VLSI stands for what? Very large scale integration. What are we integrating? Integration means what? Putting together, right? Let's take a simple example. In a house construction, what are you putting together to construct the entire house? Bricks. So you are integrating bricks, okay, to construct the house. Same way in VLSI, the basic unit is transistors. Putting together billions of transistors gives you one complex chip. How many transistors we are talking about? Billions. That is called as very large scale. You understood why we are calling it as very large scale? So since we are integrating billions of transistors, it is called as very large scale integration. How many styles are there in VLSI development process? Two. What are those two? ASIC. What does ASIC stands for? Application specific integrated circuits. It is a hardware developed for specific application only, like mobile phone chip. FPGA stands for field programmable gate array. The simple analogy for field programmable gate array could be, in real life could be, people have the container houses, ship containers will be there, right? There also people make some houses, temporary houses, something like that. You have that container, you can use that container for different reasons. The same container can be used as a house, same container can be modeled as a to use it like a office, small office rooms, anything, right? So that is called as, that is similar to field programmable gate array. Means you are changing that basic structure to as per your requirement. Whereas in ASIC, you develop everything from scratch. That means what? Once you model it as a house, it is house. You cannot change it as a office. You cannot change it as a college or anything. It will be house only. Whereas this container, what I am talking about, can be used as a house, can be used as a office, can also be modeled to work like an institute. Some whatever you want, you can model it. That will be the this. But as I said earlier, which one would you prefer? ASIC only. Let's now discuss what are the advantages. So in FPGA, same FPGA board can be programmed to behave like different applications. The same FPGA board can behave like a mobile phone. Same board can be programmed like a laptop chip. Tell me which one looks better initially to start with. Forget whatever I said earlier. Just looking at this slide, which one do you think is better option? FPGA. Because why it looks better? You're able to use same thing as a mobile, same thing as a laptop chip. So you have flexibility. Though it looks FPGA is better, industry prefers ASIC design flow due to the low cost of manufacturing. Next question comes, if ASIC is cheaper option, then why don't we do everything in ASIC? Tell me. Time taking, right? I mean, see, if I want a container house, if I place order today, within 1 week he will give me the container house. No. Let's say in my farm we want container house because we don't want to build a permanent structure. Okay. So what would I go? Container house. If I have to build my own house there, it will take at least 3 to 4 months. Whereas container house, I'll get it in 1 week. So there are few advantages FPGA has. We will discuss both. So the problem with ASIC is initial investment is large. Coming up that whole setting up a process, how you are going to do the entire thing is costly. Let's understand ASIC versus FPGA. Cost of ASIC design. Let's discuss one thing before we discuss this slide. Okay. In our country, India, right, all the VLSI related work is related to the implementation. I mean to say, all the design happens outside of India. Let's say you have a mobile phone. There is no company in India which actually develops a mobile phone design. We only the architecture happens outside of India. Let's say US, Israel, or Europe. The implementation work. See, once the whole planning is done, everything is done, you need to implement, right? That kind of work happens in India. Why do you think we don't have any company? Why do you think we cannot set up our own company? Where we initial investment is high. And it always comes with a risk. It's not just about money. It's about ability to successfully come out with that product. So if it is successful, good. Otherwise, your whole investment is gone. Somehow, people, investors here or entrepreneurs here prefer a way where it is easy to, safe bets, right? Setting up your own design house may not be a safe bet because There's always a chance that your design may have a simple bug, a small bug, then it will not work. So initial investment will be multi-million dollars. Ideally, it should have been done actually. It is possible when we are talking about some millions of dollars investment, right? And all these Jepto, all these delivery apps are getting millions or even sometimes billions of dollars of investment. It doesn't take so much to develop one chip, but anyway, that's not for today. That discussion is not for today. Ideally, it should have happened through the government encouragement or something. We should have been developing our own chips. Okay, I think that risk 5 whatever happening in IIT Madras or other things is a step towards that, I guess. Having our own processors and all those things, right? It's a step towards that. Anyway, coming back to this, what is the problem with ASIC design flow is initial investment runs into multiple million dollars. So what is $1 million in current exchange rate? 8.7 crores. $1 million is how much? 8.7 crores. So if I am talking about 10 crores, $10 million, which might be a typical cost for one entire cycle, it is 87 crores. Now, after investing that much, because why so much investment? You have to do everything from scratch. Since you have to do everything from scratch, you have to invest multi-million dollars. I mean, why you have to procure the item, softwares from the companies. So a lot of things are involved. Okay. Once the flow is working, per chip cost will be less. So once the flow is working, per chip cost will be less. Because once you know that this is the flow I have to follow, once you have that model, there will be a model. It's like you can take a simple analogy here. It's like a movie making. See, to make a movie, let's say it takes 500 crores. To make the prints, they'll make the prints, right? Various prints that is being actually brought, I mean, shown in the movies. That will be less, very, very less. Okay. So once the flow is working, per chip cost will be less. Whereas in FPGA, initial investment is less. Why? Because hardware is readily available. Initial investment is less, maybe a few lakhs of dollars, since hardware is readily available. But per chip cost will be more. I mean, manufacturing per chip will be more. So in summary, what happens is, how does that graph look is, if you want to manufacture less number of chips, you go for FPGA because that will be better in terms of the cost. If you want to manufacture lot of chips, then you go for ASIC. That is what this graph shows you. See, at this point, if I draw like this is the cost. Y-axis is what? Cost. X-axis, volume. How many chips you want to manufacture? Whatever place I have drawn the dotted line, which one is better? ASIC is better, ASIC is costly, or FPGA is costly? ASIC is costly. So FPGA is costly, sorry, ASIC is better because you can see ASIC curve is here, whereas FPGA is costing more. If I take this line, which is cheap, which is better? FPGA. Because FPGA is cheaper, ASIC is costly. Why that difference? Because initial investment for ASIC is high. That yellow line is the initial investment for ASIC. Red line is the initial investment for FPGA. But to manufacture FPGA, per chip cost will be more. So based on this, companies will decide whether they should go with ASIC or FPGA. Like I said, I have a farm, I want to have a house there. So now I have to decide between whether to construct from scratch or whether to buy a container house. How did I decide? Few factors I listed down. How quickly do I want? There are multiple things. Same way, a company which wants to manufacture some chips, it will have few things like how many chips do I want to sell. Finally, when I make this chip, will I sell only 1,000? Will I send 1 million? If if second is the option, which one will I go with? I'll go with ASIC. First one, maybe FPGA. That means anything can be done using ASIC, anything can be done using FPGA. Based on the other factors, I decide which one to go with. Any VLSI chip can be developed in either ASIC or FPGA flow. Anything can be developed with ASIC, anything can be developed with FPGA. Decision is based on cost and some other factors, majorly cost. Because why? I'll tell you. Just an example. ASIC chip cost, let's say $15. One same design, ASIC chip costs you $15. FPGA chip costs you, let's say, $50. Just example, okay. Which one will you go with? ASIC only, right? Why? When you go to market to purchase some mobile phone, okay. Let's say someone says the same specification, everything same behavior or some, very similar. One phone is available for 15,000, other phone is available for 50,000. Which one will you buy? 15,000. Okay. Same thing here. Companies, which companies go for ASIC based production? Companies which manufacture products for bulk uses. Example, mobile phone sells in millions, right? Millions of numbers. ASIC style of development is preferred. Which companies go for FPGA production? Limited applications. Companies which manufacture for limited applications. Example, hardware used in flights. I mean, let's say your uh, flights are there, right? Aeroplanes. In that one, there will be electronic systems, right? It's not purely mechanical. You know, right? Aeroplanes are not purely mechanical. They are electronics plus mechanical things, right? So whatever electronics that goes into it, who will develop that? Does it will be developed by mechanical engineer or electrical engineers? Electronics engineers, right? In those cases, you don't need lakhs of chips. Do you need lakhs of chips? Because you don't manufacture so many aeroplanes. There they go for FPGA production. That means if you go for companies like Boeing, Airbus, their teams will be FPGA teams because they will develop the chips using FPGA style. Clear? Let's now understand advantages of ASIC over FPGA. Cheaper, because I mean why it's cheaper is they come up with a prototype, one plan, then they in one plate it's like this. They'll have one silicon wafer. In that they manufacture many such things. Each one will be one chip. Each one will be one chip. Eventually, it leads to lower cost of per chip. Consumes less die area because you are customizing. You're making your own house from scratch, so you utilize the area very well, right? You'll come up with a efficient. provides flexibility to customize the features. Like when I'm building my own house, I can customize where I want to keep the balcony, where I want to keep it. With everything I can customize everything, right? That kind of customization won't be possible in FPGA. Power efficient. ASIC can work at a higher frequencies compared to FPGA, hence give better performance. For example, container house is there. Just an example. Can I keep a 4,000 liter tanks on top of that? It will collapse because of that weight. So there will be some limitations on how much you can use that container house. Whereas in ASIC, since you are developing from scratch specific to your requirement, it can customize, it can even work at higher frequencies compared to FPGA. Hence gives a better performance. Now, FPGA also has some advantages. What is the first advantage? One of the important advantages in FPGA, if you have a bug, let's say some mistake is there, you can easily rectify that because only one product will be gone. Whereas in, let's say, phone is there. In phone, some bug is there. Whatever phone you are using, some problem is there. You cannot. All other phones will have same problem. If hardware issue is there, it will be there. Then you don't have a way to fix that. You have to redo the entire process. So if a chip has a bug which is detected after manufacturing, FPGA trial won't incur major cost. We don't have to implement the entire flow again. Bug can be fixed in another FPGA board and we don't need to start from scratch. In ASIC, if there is a bug, we need to do entire flow again. Second is FPGA flow is quick. It gets over quickly, right? Because you have already the board available. You don't have to do everything from scratch. So the flow will be quick. Since we don't start from scratch, it takes less time to develop FPGA flow compared to ASIC flow. In fact, FPGA is used at one stage of ASIC design flow. Next, FPGA prototyping is used to check ASIC behavior before it is manufactured. FPGA prototyping. There is a concept called as FPGA prototyping. What is FPGA prototyping is, let's say you are working on a developing of one chip. First you check that code with FPGA. You check whether it is working with FPGA and you check the FPGA. If it is working fine, then you implement using ASIC. I'll tell you what is FPGA prototype. We want to develop a chip using ASIC step. That's final goal. We are doing through ASIC. But what we do is we check the same code, same design using FPGA board called as FPGA prototyping. Then check that FPGA board. Check the design behavior using if FPGA board functions fine, works well, works good, then design is good, right? Design is working fine. Then go for ASIC production. Then go for ASIC production. That will give you a confidence, right? That otherwise, what happens if you directly go for, if you skip this step, let's say if I don't do these steps, if I directly go for ASIC production, what if some bug is there in the ASIC? You have to redo the entire thing. That's why people do something called as FPGA prototyping. Not a very complex concept, right? Simple concept. Finally, your idea is not to sell FPGAs. You want to sell ASIC only. But you check that using FPGA. Once you see that it is working with FPGA, then you go for ASIC bulk production. I think we have already discussed. No need to spend all the time. Talking about VLSI and ASIC design flow, I mean ASIC versus FPGA flow. In this entire VLSI flow, right? There are two major steps. So the VLSI design flow has two steps. What are the two major steps? Front end domain, back end domain. This is very similar for both ASIC and FPGA. The front end domain is similar. Now, what exactly do we do in front end domain? We'll discuss after the break. Okay, but you understand that talking about front end domain, it is similar for both ASIC and FPGA. The back end domain is where it differs. It it differs a lot. Differs a lot for ASIC. So where do they differ? You understood? Now, what is pending for us to understand what is front end domain? What is back end domain? So let us discuss that after the break. So once we meet after the break, we'll discuss what exactly is the ASIC design flow, what is front end domain, what is back end domain, all those things. So if you have any questions, you can ask me now or even after the break, you can ask me. You can list down any questions. We'll first go over the questions, then we'll continue with this. Okay. So let's meet in another 12 minutes, 11:15 or so we'll meet. So
This conference will now be recorded.
let us quickly revise whatever we have discussed before the break. So we were discussing about some basics about electronic systems. We understood different layers that makes an electronic system, and we also understood the significance of hardware layer. More importantly, we understood the importance of the processor. Okay, let's in that context, let's understand why are we so much concerned about the frequency of the processor. When you buy a processor, even when you buy a laptop, what is the one important thing you look at? What is the processor frequency, right? Processor model, is it a 2.6 gigahertz, 2.9 gigahertz? Definitely you will be looking at. How do you think it is related to my mobile phone performance or laptop performance? You got my question? How you think processor frequency is related to my performance of the chip? Tell me. I'll go to this diagram. Tell me here. So as the frequency increases, that much quickly it will get the instructions, and that much quickly it will do the transfers. So you draw two clocks. Let's say I draw one clock which is running at 1 gigahertz. Let's say this is how that clock is. Let me draw another clock which is running at 2 gigahertz. So this is what? 1 gigahertz. Let me draw another clock which is running at 2 gigahertz. How it will look like? Though not exactly this one. You understand, right? Which one is having higher frequency, the blue one or red one? Red one, because more frequently edges are happening, right? In the red one, you see more frequently the edges are happening. So this is which frequency? 2 gigahertz. When my processor works at 2 gigahertz, it will fetch more instructions here, 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 like this. Whereas in 1 gigahertz, how many in the same duration, how many it can fetch? 1, 2, 3. Okay. So in a given amount of time, with 1 gigahertz, if I can fetch 4 instructions, with 2 gigahertz, 8 instructions. So 8, double the work will happen in the same amount of time. That is why we are always concerned about what is the frequency of operation of the electronic system, right? And more importantly, it is for processor. You see, other components are also working actually. USB is working at some frequency, DDR is working at some frequency, but more importantly, we are concerned about processor frequency because processor is the master of entire system. Processor is the one which executes everything. Got it, right? Next. Now let's understand ASIC design flow. Okay. So before that, have you understood what is difference between ASIC and FPGA? But you got some idea, right? You don't need. I don't expect you to be perfect with everything, but at least if I ask you, what is ASIC? It's a style of VLSI development where you develop everything from scratch. So, coding of RTL, implementation, everything done from scratch. In FPGA, you already have a FPGA board available. On that, you implement your design. You program your design, program the board as per your requirement. That's why the term field programmable. I mean, you program the board as per your requirement. Now let us talk about ASIC design flow. First, let's understand a simple analogy for ASIC design flow. Why we take analogies? Because you can easily correlate whatever analogies we take. Here we'll take an example of house construction flow. Right? So how does house construction start with? What do you think? Let's say you want to construct a house. What will be the first thing you do? When I want to construct a house, a big house, for a small room, fine. For a big house, what will be the first thing you will do? Sorry,
Cost estimation.
cost estimation. Before that, what do you do? Foundation. Before that,
Plan.
planning. Before that, before planning, what do you do? First, write down your requirements. What kind of house do I want? How many floors I want? How many rooms I want? What type of flooring I want? What kind of walls do I want? You'll write down, right? You'll first before you do anything, you write down your requirements. With requirements, whom do you go to? Whom will you go to? Taking requirements, whom will you go to? Go to whom? Architect, right? What architect will ask you? What is your requirements? Architect will ask you, what is your requirement? Then what he will give you? Entire thing. Architecture, the various plans he will give you. Electric plan, plumbing plan, plinth, everything he will give you, right? Then whom do you go in next step? Some contractor will be there or some maestri will be there. For him, what is the input? Whatever is the output from previous stage, that is his input. You go to a contractor, he won't again ask you requirements, he will tell me, give me the plans. Then what he will give you? The basic building structure. He will construct the building structure and give you. Next, whom do you go to? Then there are various people. Plumber, carpenter, painter, many people are there. You see, so many people are involved in house construction. Right? Can one person do entire work? No, right? Same way with ASIC design flow, one person cannot do everything. In which case one person can do everything? Let's take house construction only. In which case one person can. If you are building a small room, I can have one person do everything because it's a very simple requirement. If the design is more complex, house is more complex, you need more people to be involved in. Same thing with ASIC design flow also. You can divide it into almost 15 steps. The entire ASIC design flow can be divided into what? 15 steps. Divided majorly into two categories. One is called as front end domain, the other one is called as back end domain. The front end domain starts with what? Requirements. You can exactly correlate. The way you construct house, what is the first thing you started with? Requirements. Here also it starts with requirements. In your chip, in your mobile phone, you will ask my chip architect, let's say it's some company, this company will have an architect. That architect will ask, what is your requirements? What kind of phone you want to come out with? What kind of display you want? What kind of camera you want? What kind of USB? What type of processor? How much performance do you want? Right? Do you think this phone and some other simple phone will they give same performance? No, right? They have different performance. All these things are input to the architect. So then architect will give you what? Architecture, different documents, diagram, specification, everything in between. Then whom do you go to? Like we had contractor, Masonry, right? The person who was responsible for developing the structure. Who is the similar people here in our VLSI? RTL design people. So who is similar to contractor and Masonry in our VLSI? RTL design engineer. He develops the design. Okay. Next step is called as integration. See, generally what happens when they develop, right? They we don't have one person do everything. We have multiple people developing small blocks. Let's say this block is developed by someone. This block is developed by someone. The person who develops these blocks are called as designers. Then you have to put together everything. That is called as what? Integration. Simple term, right? Integrating the smaller designs. That is called as what? RTL integration, right? Next, what do you have? RTL functional verification. Whatever coding that is done. See, RTL means register transfer level, which is done using which language? Verilog. Whether that coding is done properly or not is checked by functional level. If you don't check, what will happen? If you don't check it, what is going to happen? Tell me. If there is some mistake in the code, that will come into my phone finally. Whatever mistake that is there in the code, in the RTL code, it will finally appear in my phone. Then will my phone work properly? It won't work properly, right? Then I won't be able to use it. That is why we have to verify the RTL design. Whatever coding you have done, that needs to be verified because you want to make sure that your chip don't have any mistakes. Bugs should not be there. After that, what is the next step? DFT, design for testability at coding level, at Verilog level. This entire steps collectively we can call as what? Front end domain. So tell me, where does the front end domain start with? Requirements. You list down the requirements. Then what is the next step? Architecture. Next step? RTL design. Next, integrate. Next, do verification. What type of verification? Functional verification. Is it functionally correct? Then you DFT, design for testability at the RTL level. Okay, now do you need to learn everything as a beginner, as a fresher? Do you need to learn everything? No. Let's say you take an example of house construction. Okay, I want to hire some people for my house construction. So will I hire a person who knows small amount of everything? Let's say he knows some amount of carpentry, he knows some amount of plumbing work, he knows some little bit of electrician work. That is first option. Second option is what? He is expert in carpentry. He doesn't know anything about plumbing. He doesn't know anything about painting, but he is expert in what? Carpentry. Will I go for first person or second person? Second person. Tell me, in all cases, what will you, as a sensible person, what should I do? Will I go with the option that, okay, this guy knows everything small, okay, he will reduce my cost? Or should I go for the second person? Second person. Because I know that if the person is expert in carpentry, he will do that carpentry work, wooden work in such a way that I won't have any issues going forward. Otherwise, if he knows small amount, he will design a wooden work where after 6 months, I'll start getting the problems. This is how companies always hire the people. They don't expect you to be expert in everything, which is not possible. Is it possible in real life, in house construction activity, to one person to have expertise with everything? No. Tell me, when do you think some person would have developed such expertise? Forget VLSI, in house construction example, at what stage do you think some person would have expertise with everything, carpentry, plumbing, everything? After some 15-20 years, where he has tried 5 years of carpentry work, then out of his passion is moved to plumbing, out of his passion is moved to some other work. Same thing in VLSI also. As a beginner, they don't expect you to know everything. Little bit of some basic idea is good, but you should be expert in one domain. How much expert? I told you the carpentry example, right? That they should have complete confidence that you can do entire thing properly. Yeah, fine. Coming back to the next step, we have seen what goes into front end domain. Now let us talk about the next domain called as back end domain. It starts with an important step called as synthesis. The back end domain starts with an important step called as synthesis. What is synthesis? Process of converting your RTL code. You have RTL code into gate level code. Now I will explain later what is Verilog RTL is. You know, there will be coding like always, at the rate of passage of clock, initial, assign. There are multiple codes will be there. Converting that into gate level format. Gate level means what? AND gate, OR gate, NAND gate, multiplexer. That will be called as gate level. So converting Verilog RTL code into gate level format is called as synthesis. In both the cases, you are referring to the same design. Whether it is Verilog RTL level or gate level, both are referring to the same design. But what synthesis does, it converts this format into this format. Why do you need to convert it? Tell me, what happens if I don't convert? Because when I go and purchase some electronic product, let's say I'm purchasing a phone, he will not sell the design RTL code to me. He will sell me the physical piece of phone. Understand that? Whenever I buy a phone, I buy the physical piece. So the initial step for that is called as gate level code. This gate level code is taken through various steps. DFT, physical design. What is physical design means? Like planning the chip. If this is my chip area, where the processor core should be kept, where the GPU should be kept, where the memory controller should be kept. That entire planning in this small area is called as physical design. You can simply imagine you have a desk. On desk you want to keep 20 items like pen box, some laptop, some notebook, different items. How do you arrange them? How do you arrange them? That is called as physical design. Okay. It is more than that. I mean, it's not simply arranging. It is more than that. It's a physical design itself is a complex topic in itself. Okay. So once the physical design done, what is the next step? STA, static timing. So what is the next step? Static timing analysis. Then what do? Custom layout. Layout means we draw the layouts. You know, right? Layouts are drawn at the MOSFET level, at MOSFET or FinFET level. The gate, drain, source, substrate, the metal. Drawing to that level is called as layout. You draw the layout. Till that time before that, what was there? It was in the gate format. Let me explain here. Here the design is in document format. You know, a document which tells how it will behave. Here the design is in Verilog RTL format. Format means that is how coding is done. From here to here, gate level format. Here it converts to transistor level, MOSFET or FinFET, whatever. There you draw, since you have MOSFET, you have to draw the layouts, right? Individual layouts. That is custom layout. Next, what? You have to do the physical verification. So what is involved in physical verification is checking the basic rules. See, when actually speaking, chip will be very complex beyond our imagination. How the chip will look like is very complex. How complex, I'll tell you, just to give you a feel. You have a small area. How much area? 1 centimeter this side, 1 centimeter this side, assume. Into which how many transistors are going or gates are going? 100 crore. 1 billion means 100 crore. Each transistor requires at minimum what? Source and ground. Source, you know, right, how transistor looks like? Source, drain, gate. For every transistor you have to supply a voltage. For every transistor. So you have to supply current for what? 100 crore transistors. And you have to connect all of them to the drain. So a lot of complexity actually involved. I mean, it's very difficult to imagine at this stage, but if you get into that level, you will see a lot of complexity. Idea is not to tell that it is very complex subject. Idea is how do you develop interest in something. I mean, you should be excited about learning so complex. There are two ways, right? One is you think I cannot do, it's too complex, I cannot do it at all. Second is what? It is complex, it is very interesting to learn. I should develop passion and I should become expert in that. So which one do you want to be? Second one, right? That is what I am trying to help you understand. I mean, you are going to develop things of that complexity level. Next is what? Finally, once you have done, you do something called as GDS2 extraction. What does it stands for? Graphic Design System. I'll give you a simple analogy for that. You know, right, in movie making, it goes through various process. You know, production, movie production goes through various stages. Finally, what do they release? Some file they will release, right? MP4 or whatever. They'll give a movie file to some theater in some format, right? So that they will project that movie. They'll show the movie through that file. Similar to that in our VLSI is the GDS2 file. Once you have done the entire chip process, what you get is the GDS2 file. If someone can take away that GDS file, let's say someone can steal that GDS2 file, they got all your work. You know what? Got it, right? Earlier, sometime back in 20 years back, China used to release some phones which are not in market. I believe they used to do something like this probably. At that time, they used to get the GDS2 and develop their own chips. That's what I would have happened. So, in summary, whatever work you have done in this thing, whole thing, goes into this single file, GDS2 file. This is similar to MP4 file. What is MP4 file? Tell me. The entire movie is present in MP4, right? Starting from the title till end, everything is there. Audio, video, everything is there, right? Same thing, the way movie is captured in MP4 file, my entire chip information, where the substrate will be there, where the where the source should come, where the drain should come, where the metal should come, where the polysilicon should be deposited, how much doping to do, is all defined in GDS. That's why we call it as graphic design system. It will show as a graphic design what to do where. So once you have that file, you can manufacture the chip. In ASIC, what happens is, this is the costliest process. This whole thing, doing this entire thing, this is the costly process. Once you have this file, per chip manufacturing is very cheap. Then it goes for what? Fabrication. After fabrication, post silicon validation. Whatever you have fabricated, you have to check whether is there any problem in that chip that is fabricated. Okay. Finally, once you have verified that chip is working fine, each chip, you go for packaging. Once you are done with packaging, get this. So where did this start with? Requirement, and you know all these steps. Then it went through backend domain. So in summary, what is backend domain? Process of converting the RTL code into this one. That entire process is what we call as a backend domain. In software, there is no backend domain. Why? Because we are only developing the code and that code is finally deployed. In software, what happens? Anytime you develop a software, let's say some hotel restaurant person comes to me asking to develop a simple billing software. He wants a billing software what? For all the breakfast and lunch menu items, right? When I tell 2 idli, 2 vada, he will give me the bill. So there is a software which generates that bill, right? So will I give him a code or will I give him a piece of hardware? Code, which is installed in his system and he will use it. So in software, there is no need to fabricate things. So in software, this entire process won't be there at all. Software engineers don't have this process. Their work starts with the developing the code, testing of the code only. Their work starts where? Develop the code, test that code is working fine, then you start deploying. Whereas in VLSI, ASIC, whatever code you have developed, you have to convert it into gate level format. You want to take it through DFT, physical design, STA, custom layout, physical verification. Finally, till the time you fabricate, check it. That is why it is very costly. You see, that's where you may see a lot of companies in India are software development. There will be many software development companies will also be there. But you won't see many companies into ASIC production, because there won't be many companies for ASIC, chip design, because it is very costly. And finally, if this phone, once you have manufactured, has some mistake, you have to do the entire process again. Lot of things again you have to do. Now let us briefly talk about VLSI front end domain. Okay, let me revise again. In VLSI, how many major domains are there? Categories are there? Two: front end domain, back end domain. Front end domain starts with requirements till the time we do verification and basic DFT. Back end domain starts with what? Synthesis, ends with post silicon validation and then packaging. Now let's talk about front end domain. We'll more specifically focus front end domain because this is our today's demo session topic, right? Our demo session is on front end domain. So let's discuss about front end domain. See, the front end domain is very similar to software job role, software flow actually. In software engineer, for a software engineer, what is the skill set? Knowing some languages, C, C++, Java. They should be good at reading the software specifications, right? Given a specification, they should read and understand what is the software requirements and everything. They should develop algorithm and implement the same using C, C++, or Java or similar languages. They should have good programming skills. The software engineer should have good programming skills, right? What about VLSI front end domain engineer? They should know Verilog SV. Verilog is similar to C language. System Verilog is similar to C++. UVM is similar to Java. Verilog is similar to C. I told you, right? This is the requirement. Okay. They should be good with programming or have inclination towards programming. If you want to get into front end domain, I will not ask you, are you good with Verilog? You should have willingness to learn Verilog. You should not think that, you should not come with the mindset that programming I cannot do. Even if you didn't do for 4 years, like during electronics BTech, you wouldn't have done maybe C language in first or second semester, you would have done. But you should still have a confidence that I can learn the program. I'll tell you one thing actually regarding programming. It's about learning a new language, right? It's much simpler than learning any of our native language. Let's say you are from any language, let's say Telugu, Kannada, anything, right? Learning a new language, Hindi, anything, right? It'll have its own challenges, right? You have to learn what is past tense, present tense, future tense, so many things you have to learn. Compared to that, learning a language here is much, much simpler. Why? If I have to learn Kannada today, I have to learn at least 300 new words. 300 new words, and I have to learn what is the meaning, how, in what context to use, what is the tense, I have to, all those things, right? In languages like Verilog, see how many words are there here in Kannada? 300, for example. If I want to learn Verilog, there are only 30 words I have to learn. How many words? 30. Assign, always, if, case statement, for loop, while loop, which is much simpler than learning any language. I'm trying to tell you that you should look always at a simpler side. You should not think that things are very complex. I cannot do programming. It's easy to learn programming because any language you take, C language, Verilog language, they don't have as many things as we have in our languages, like Telugu, Kannada, Tamil, Hindi, all right. We have a lot of words to learn. Each has its own context. Each has its own meaning, right? We have same word can have different context. In programming, you don't have all that confusion. It's very, very simple, very straightforward. No past tense, no future tense, nothing. A very simple meaning will be there. You just have to get used to that. You should develop that passion. You understood, right? You should read the hardware design specifications and understand the design functionality, because when you are developing a hardware, when you are verifying, you should understand, right, how does that hardware behave, and implement it using different protocols. What kind of protocols? USB, PCI Express, DDR, AMBA, various protocols. Now, again, do we expect you to come with all these things? Expertise? No. Whatever is required for you, will everything will be taught from the basic. Just that you should have that willingness to learn, and you should have confidence in yourself. What is the confidence? I can learn. Okay, willingness is what? Ability to spend time. See, okay, I want to do lot of things, okay. But if I don't spend 1 minute also, can I learn? All right. See, I want to do many courses. Actually, this month, by end of this month, I want to release 2 courses. LPDDR5. Let's say today I'm learning. And I want to finish that course by end of this month. But if I don't spend even 1 hour, can I release the course by end of this month? All right. So I have willingness. I mean, but I should parallelly spend the time to do that. Same thing for you also. First, you should have that passion to do, and you should take out enough time to pursue that passion also. Next. Where does VLSI differ from software? Tell me. We just now discussed. What is that differs? Where is VLSI different from software domain? Backend domain. VLSI needs a backend domain. Software doesn't need a backend domain. Software doesn't require backend domain flow. What is backend domain flow? The process of converting Verilog code into a chip. That entire process is called as backend domain. In software, code is installed and used. No need to manufacture as a chip. You don't need to manufacture the software as a chip. In VLSI, the functional verification plays a very important role. If there is a bug in a chip which is detected once it is in production, bug cannot be fixed. Let's say once this phone is manufactured, inside the phone there is a hardware issue is there. I cannot do anything about this phone. I cannot do anything. I have to redo the entire phone design again from scratch. Whereas in software, so VLSI chips don't have a concept of patch. What happens in software? Tell me. If there is a bug, it can be fixed. It will be released as a new version of the software called as patch. You know, right? For software, they keep giving patches. Have you heard of the term patch? Software patch. What is software patch? That's what some bug is there in the software. Actually, they release a fixed version, new version. That's the patch. In VLSI, there is no concept of patch. Once there is a bug, you have to redo the entire thing again. You cannot go and do small fixes in the chip. Got it. That's why in VLSI, verification plays a very important role. The domain which you are choosing, right? Most of you are joining for what? Functional verification course. That's why it plays a very important role. In software, it's not so important, because even there is a bug, company will not close down. They'll identify the bug, they'll fix it, release a software patch. In VLSI, you cannot release a patch, you have to redo the entire thing. There could be times where companies shut down because one chip has a bug. They released a product that has a bug. Let's say my company, I set up a company, I have an investment of 50 crores. That whole 50 crores I invested in one chip, and that chip has a bug. Then how can I do next chip? I don't have anything. In software, that problem won't be there. You identify the bug, you know where is the bug, fix it, release it. So where does the verification plays more important role? VLSI, right? Because if you don't identify, that's a problem. If you don't identify, 100% it will come in the chip, right, in the phone. Once it is gone, it will come to all the phones. That's why it plays important. Now let's briefly understand. I'm not talking about backend domain, because if you are interested in backend domain, you can attend tomorrow's demo session. Because more I talk, it will unnecessarily extend the session. Rather, if you want to understand what is backend domain, you can attend tomorrow's session. Okay, I suggest you to attend, because it's about you have to keep gaining that knowledge. I hope something new you might have learned today. There will be something more to learn tomorrow also. Fine. Let's talk about VLSI domain. What are the job roles? Before we get into that, let's go back to analogy. What was the analogy for VLSI design flow? For ASIC design flow, what is the analogy we took? House construction. In house construction work, how many job roles are there? Labor, contractor, plumber, carpenter, painter, electrician, tiles person. Similarly, in VLSI also, there are multiple job roles out there. One person will not do entire work. One person will not do the entire work. So there are different people doing different works. You have to identify what is the right domain for me, and you have to develop expertise in that domain. During this process, at any point of time you feel that I have made a wrong decision, I should have gone to some other domain, will give you that flexibility with no additional cost. In VLSI domain, job roles are front end domain, back end domain. In front end domain, design requirements, the company which works on design requirements is the marketing team. Architecture work is done by chip architect. RTL coding is done by RTL design engineer. Integration is done by RTL integration engineer. RTL functional verification is done by functional verification engineer. You can even call him RTL verification engineer. RTL verification engineer. RTL designer, RTL integration engineer, RTL verification engineer. DFT person who does is called as DFT engineer. Synthesis person is called as, see, simple, the term and the engineer. So the point is, so many job roles are there. Like in house construction, we said around 10 to 12 job roles are there. Plumber, painter, carpenter. Here also, architect, RTL design engineer, RTL integration engineer, functional verification engineer, DFT engineer, synthesis engineer. So different roles are there even in VLSI. You have to choose a domain which is of interest to you. So here, let's briefly talk about what is a ASIC team distribution. Let's say if you get into a project, there are 50 members in the team. How many members are there in the team? 50. What is the team is for? Mobile phone chip manufacturing. What does the team will do? Let's say I set up a team. I want to set up a team. For what purpose? I want to develop. I took a challenge that we should have our own mobile phone chip as a country. Right now we don't have. Everything is imported. Right? Let's say we think that we should have our own chip. So what is my process? First, architect requirements. Same thing I have to do, right? What is my requirements? Then I have to go to architect. In this planning, in this whole thing, I will need some team, right? Let's say the team is how much? 50 people. That 50 people will have around, front end domain will have around 25 to 30 people. Front end domain will have how many people? Around 25 to 30, which is around 50 to 60%. Then back end domain will have how many? Remaining, right? (20 to 25). The range, I'm not telling exact 20, exact 25. It's always possible, right? If I ask how many labors are required for construction, it could be 5, it could be 6, it could be 7. So I cannot always say 5. In front end domain, how many architects will be required? One good architect. Let's say you want to construct a house. Do you go to 5 architects or you go to one good architect? One, right? Design team will have how many people required? Tell me. Around 4 to 6 people. But verification requires how many? 15, 20. So which team requires more people? That's because actually you may say why it requires less people. This requires more people. It is because design work happens through IPs. IP stands for intellectual property. In intellectual property, what happens is whatever I need, I buy from someone else. Let's say I want a now, as I said, I'm setting up a company for mobile SoC, right? I will not do everything from scratch. What I will do, I'll go to ARM company. I'll tell them that I want your processor IP. You know ARM processors? Have you heard of ARM processors? All this Qualcomm, everything process that goes into most of our mobile phones is based on the ARM architecture. They're all based on ARM architecture, either ARM version 8 architecture, version 9 architecture, one of them. I will not do myself. I'll go to ARM company. I'll tell I want to use your processor IP. So I'll pay them some money. They'll give me license. I want DDR controller. What controller? DDR controller. I'll go to Synopsys. I'll tell them I want DDR4 controller. I'll pay them. They'll give me the controller, not the hardware. They'll give me the code. Like that, I'll get all IPs from different companies. So in that case, do I need a big team internally? No. That's why less people. But when I'm verifying, I have to verify everything thoroughly, right? Is everything working fine or not? There I need more verification engineers. So how much percentage of the team is verification engineers overall? 30 to 40%. Up to 40% of the team of my 50 people, up to 40% itself is verification team. Backend domain will have how many people? 20 to 25. DFT will require 2 to 5 people. Physical design will require 10 to 15 people. STA will require 3 to 5 people. Layout will require 3 to 5 people. So, which are the 2 domains where there are bulk requirements, bulk number of people required? Okay, that is where lot of fresher hiring also happens. Why? Because when you have so many people, they can hire some freshers. If you need only one person, can you go for a fresher? I'll go for most experienced person, right? Same where there are less requirements, they will manage with experienced people. Where there are more people, they will mix some experienced, some freshers. I'll just briefly talk about DFT. Okay. Because some of you might be for. How many of you are interested in DFT here? No one. Anyone attending online? Are you interested in DFT? Okay, Kishore. Okay. See, DFT is about. DFT stands for design for testability. What happens in the chip, right? When you're fabricating at very low technology node. What is the current technology node is 3 nanometer. Even you may have something coming in 1 nanometer node also. Let's not anyway talk about that. 3 nanometer. 3 nanometer is very, very small. You cannot even imagine that how small it is. We cannot imagine. Why? Because whatever hair thickness you take, that will be around how much? Maybe some 0.1 micrometer. My hair thickness will be zero point 0.1 millimeter. Let's say hair thickness is what? 0.1 millimeter. Okay. What is 1 nanometer is this divided by, you take the hair, vertically cut it 1 lakh times. Whatever hair you have, that vertically cut it by how much time? 1 lakh. Like if this is the hair, you vertically divide it 1 lakh times. What you get is a 1 nanometer. Very, very hard to imagine also, right? What is 1 nanometer? At the technology node, what is technology node here? The distance between drain and the source. You know, right? Channel length. There is a channel that forms between drain and source. That gap is called as channel length. That is the 3 nanometer we are talking. At that level, when you are manufacturing, even a small dust particle, smallest dust particle goes, it can spoil that chip. For different reasons, not just for dust particle, for anything, chip can go wrong, right? For anything, chip may have, they are called as manufacturing defects. If I tell me, is there any manufacturing defect in this chip? You cannot tell. Looking at the phone, you cannot tell. So there is a process that is required to identify that manufacturing defects. Okay. So there are different manufacturing defects called as stuck at fault, stuck at zero fault, stuck at one fault, at speed fault. DFT engineer develops test patterns which help detect the manufacturing defects in the chip. Example, a sample test pattern is like this. Some random number here, let's say 1010 some number. Okay, if you ask me how did you come with that number, he has some techniques. DFT engineer uses some techniques called as scan, built-in self-test, boundary scan, JTAG, different techniques. Through that he comes up with these numbers. It's not like a randomly he decides, okay, 1, next 0, next 1. No, there is a process he follows to come up with these numbers. This pattern is applied to the chip. Chip output tells whether the chip is good or faulty. It's like I have a chip, I apply this pattern here. Whatever output I get, I will check that and say it's good or it's faulty. DFT engineer uses various techniques to generate about test pattern. What are the techniques he uses? Scan, ATPG, BIST, JTAG, boundary scan, compression. So multiple techniques. I mean, in case you are going for, let's say, DFT training, it is not, I mean, this entire thing will be spread over 4 to 5 months of learning. So hence you can easily learn. Don't think that these are very complex, right? Everything, lot of things are new, right? You learn for first time. As I told you, you have to give time and you should have that attitude to learn. Same thing with DFT also. Everything our trainer will teach from basics with practical examples. You should have willingness to spend time and learn things. So these test vectors, what are the test vectors I spoke? Something like this. Okay, some long series of numbers are given as input to whom? Post silicon validation engineer. There is a person in the team called as post silicon validation engineer. What does he do? He applies this test pattern to the chip and tells whether chip is good, chip is bad. So finally, once you have the chips coming after fabrication, whose responsibility is to tell whether chip is good or bad? Post silicon validation engineer. What does he do? Output of the chip indicate if the chip is working fine, if there are any manufacturing defects. If there are defects, chip is not used for packaging. If the chip is good, it is finely packaged and you get the phone, you get the final product. So percentage of good chips is called as what? Yield, right? See, yield is how much percentage of chips is good. Out of 100 chips, let's say 82 are good, then what is the yield? 82%. 5 minutes. Okay, so that concludes basics about DFT. We'll just briefly talk about verification, what exactly we mean by functional verification. Then we'll go to the remaining schedule and question and answers. Because this is being a verification demo session, I should talk a little bit about verification, right? Not like a very generic VLSI flow. Let's briefly talk about what is verification. The role of a verification engineer can be called as functional verification engineer, RTL verification engineer, design verification engineer. Everyone is same. Okay. Role of a design engineer, verification engineer is, in my design under test. See, design, there is some bug here. Somewhere in the design, some bug is there. His role is to identify that. He has to point out that there is a mistake here. Somewhere in your code, you have done a mistake. You have to tell to the design person that you have done a mistake. For that, what design engineer does, verification engineer does is, he sets up this kind of entire test bench. This green box you see, that entire green box, whatever U-shaped box I have made, that is called as test bench. This is the code I got from the design person. Who has given, what is the DUT stands for? Design under test. Who gave me DUT? Design engineer. Now my role is to check, is everything good inside this? Is there any faults? Any coding mistakes are there? So as part of that, what will I do? I set up a test bench around this. I develop some BFM code, generator code, monitor, coverage, reference model, register model, checker, scoreboard, many things I develop. Got it right? I develop many things. And using that, I will check, is there any mistakes inside this code? If there is any mistakes, it will be caught at this level. There is a checker. Do you see checker here? Checker is for checking purpose. Scoreboard is for keeping track, how many passes happened, how many failures happened. For now, this much. I don't want to go too much deep because it may confuse you, or I don't want it to be too exhaustive for first day. But you got the basic idea, right? You got the design from a team. What is it? Which is the person who gave you this design? Design engineer, RTL design engineer. Your role as a verification engineer to make sure that there should, what is the code used in DUT development? Verilog language. Which language is used? Verilog. In coding, he might have done some mistakes, right? Possible, right? When I am developing 10,000 lines of code, when I'm developing 10,000 lines of code, there's a possibility that one line might have gone wrong. Instead of adding, I may have written subtraction. Instead of else condition, I may have done something else. Some or other mistake possibly I could have done. So the verification engineer role is to identify that this is the mistake you have done. If I don't identify, it will finally go into the chip. That whatever mistake, instead of plus minus will happen, right? That mistake will go into the chip and my design won't work properly. So for that purpose, as a verification engineer, what do? I set up the test bench. Tell me, who develops the test bench? Design engineer or verification engineer? Verification. So that means BFM is developed by whom? Verification engineer. Means I, verification engineer. Generator, I. So except for this one, everything else you see is developed by verification engineer. Now, how do we develop it? How it verifies the design is what is to be discussed over 8 months of training. So I don't want to explain everything in 10 minutes and confuse you. This whole process will be discussed over 8 months of training. It is not as complex as you may be thinking. It's not complex. It's a very simple. See, finally you write down the baseline. What is the baseline requirement? Someone has developed the code. There may be some mistakes, possibly. If everything is good, perfect, no problem. If some mistake is there, your role as a verification engineer is to identify where is the mistake. For that, you have to follow some process that is called as functional verification process. One important part of that process is setting up the test bench, this diagram, and develop the code as per this. Okay. Now let's get into training schedule. And before this, one just brief thing. That where does system Verilog come into picture here? This entire thing is developed using system Verilog language. Whereas this is mostly developed using Verilog. Design is developed using Verilog. Test bench is developed using system Verilog. Now, why is it so? We'll discuss as we go forward. Now let's come into the generic topics: schedule, support, placements, other things. See, the training schedule, there are 2 or 3 modes of training. One is full week mode of training and weekend only mode of training. In some cases, weekdays, evening batches. Full week training is available in online, offline, and hybrid model. You can attend online if you want. You can do 100% offline also, like the way you are attending in classroom, like the way people are attending online. They can attend 100% course online. You can even do hybrid. What is hybrid? 2 months you attended offline, 2 months you went home, attend online, again come back and attend offline. That is possible. Vice versa, even online person can come here and again go back home. That is also possible. In this mode, you get access to the recorded videos for 2 weeks for every session, minimum 2 weeks. Let's say today I have done a session. This session is being recorded. This will be given access to you for at least 2 weeks. It could be more than that, but minimum 2 weeks it will be given. Weekend only training. In weekend only training, currently it's only done online only. No offline is there. And if you want to come offline and get a support, dedicated mentor will be there for offline doubt clarification. Let's say you can come down on Saturday, you can connect with the trainer, clarify your doubts. Here in weekend only mode, you get access to all the recorded videos for entire course duration. Throughout the duration, you will have access to each and every video. There is no 2 week restriction. The third mode is what? Weekday evening batches. It's sometimes working professional want weekdays evening batches, but this is subject to some minimum requirement. Minimum, we should have some minimum 5 to 6 people like that. Only then we do the evening batches. If there is only one person, he says I want weekend evening batches, we don't do, because we have to see whether it's feasible to do or not. In that case, that person can do weekend batch. Next, all modes of training
Every student assigned with a dedicated mentor for doubt clarification. Now let's talk about briefly about functional verification training, the one in which you are attending. It goes for 8 months duration. Many institute you might see their courses will be for 6 months only. Many places, even we started as a 6 months only, 5 months, then we increased to 5.5, 6 months. Now it is 8 months actually. Why it is 8 months is most of the people who come to this course are from electrical electronics background. This functional verification domain is a more programming oriented job. You need to learn Verilog, system Verilog. You should have the coding related aspects. If you are new to coding, learning everything in 5 6 months becomes challenge. It's not just learning coding actually. You have to learn digital design, advanced, properly, in depth, everything. You have to learn some standard protocols. You have to do a lot of projects. So many things are there. If it is only learning language, 3 to 4 months is sufficient. But since you are learning things other than these things, it takes so much time. In this 8 months, actually our back-end course is not 8 months. It only goes for maximum 6.5 to 7 months. Physical design is only 6.5 months course. Why? There they don't need any coding. It's mostly semiconductor concepts. So we don't have to spend same amount of time what is required. In this 8 months, we'll have training 6 days per week. Sunday will be off, and around 5 hours per day. 2 hours of theory session, 3 hours of lab session. Lab session means we will be giving you assignments. You will be working on those assignments with the trainer support. Every session recorded video access for 2 weeks. We have our platform called as inskill.in where you get access to the recorded videos. There all the course material, everything will be available. All the presentations, assignments and the notes, everything will be present in that portal. Printed material also will be provided to you. Whether you enroll for online training, offline training, will give you the printed material. If you are attending online, the material will be posted to your house anywhere in India. Next. Similarly, we have, talking about functional verification training, it is divided into 3 phases. First phase is for around 3 months, second phase is for 3 months, third phase is for around 2 to 2.5 months. During phase 1, we do advanced digital design, Verilog language, Verilog projects. We also do GVim text editor, some other essential things. Phase 2, we do system Verilog and UVM, Linux commands and soft skill training. And from here, placement support will start. Means you don't have to wait for 8 months to get the job. Your placement support will start from 5.5 months. Let me tell you, for someone who is not good, placement support even may take 10 months also. Because if you don't have the required basics also, we cannot consider your profile to a companies. You understand that when a company hires you, they expect you to come with some skill set. So that if you learn, you can get even placement support from the 4th month itself. It all depends upon how well you prepare and how well you learn the subject. And we will also do at the end of this 6 months, 1 month dedicated interview focused training will be done, which is outside 8 months actually. Just to make sure that what is that 1 month is for revising everything. Revising all the topics of important questions of digital, important questions of Verilog, system Verilog, UVM, everything. Because it is equally important to clear the interview also, right? Learn the subject and you should be clearing the interview. That is where that is the whole goal, right? Of course. Next, 1 month is revision of everything. Important questions are discussed. The final phase is important one actually. This is where your practical, very practical training will happen. What is very practical means you learn the actual industry level projects. Multiple industry standard projects like AXI, AHB, APB, multiple projects will be done during that period. Python scripting, SOC flow basics. See, phase 1 and phase 2 helps in getting job. Phase, yeah. Sorry, you want to? Yeah, please. Phase 1 and phase 2 helps in getting the job. Phase 3 helps you perform in the job. See, once you join the job, this industry standard project, what we do, will be very helpful to you. Because when you go to industry, you should be familiar with how the project flow works, what kind of issues are seen, how to resolve those things. These projects will help you. So most of the other institutes, I know their training stops with this thing actually. They don't do this level of projects actually. I mean, it's not good for me to say negative about other institute, but I have to tell, right, why this much duration. So what is the difference? Do they do same thing in 6 months? We do same thing for 6 months, but then we spend additional time to make sure that you learn the industry relevant work. Most of the other institute, their work will be on a small project, which will not meet the industry requirements. That's the big problem. Finally, the next one is experienced person training, functional verification for experience. Uh, Here, what I'll just briefly summarize this and close for today. This one. It is for only 6.5 months, 6 days per week. Here, the difference is for when you go for experienced person, there won't be any digital and Verilog. Their training directly starts with phase 2. There is no phase 1. It directly starts with phase 2. Again, as I said, phase 1, phase 2 will be there. For other domains, let's not get into it because I don't think many of you are looking for FPGA training. Okay. Even DFT, our trainer will explain during the DFT demo session. And physical design demo session. Tomorrow you can attend if you are interested in this one. Next, how do you choose the right course? As I said, first thing, you have to identify what is your domain of interest. I've given a brief about what is expected in front-end domain, what is expected in back-end domain, right? Front-end domain involves more of programming kind of skill set, understanding the protocol. Front-end domain don't need any semiconductor basics. If you get into front-end domain, you don't even need to know what is FinFET, what is CMOS. You don't need to know what is short channel effect, second order effect, nothing. Whereas when you come to back-end domain, you should be knowing at that level how the FinFET will work. Okay, what are second order effects, what is short channel effects, everything you should be very comfortable with. Other than that, if you have front-end domain requires programming expertise, you should be little bit inclined towards programming skills. In back-end domain, no programming, very less programming. Some TCL scripting is required, which don't require too much programming. Okay. So based on that, you can choose. As I said earlier, you should also be open for choosing FPGA domain. Because someone said you should not take physical design, because someone suggested you should not take only design verification, you should also be open to taking FPGA design course as well. Because I said one statement, you should choose domains where there is a less competition is there. Simple, right? Everything works on a supply demand. Why things are so costly in Bangalore? Land cost, everything. Is it different from something in our villages? Is it land something made of something else? No. Here there is a more demand is there, so automatically price is high. So same thing works in job market also. You have to choose a domain where there is a less supply, less number of people, but still has a scope. Okay. So there I have given 3 possible things. If you are interested in programming skills, you can go for functional verification. FPGA will suit middle in between. Like you don't need to be expert in coding. Yes, it requires coding, but it also involves something of flow based training. I mean, you need to know how to implement the FPGA flow. If you don't like any of these, if you don't want any coding at all, go for backend domain. Backend domain will involve physical design, DFT, STA, custom layout, requiring no programming expertise, mostly tool and technology oriented job. The job will be mostly tool and technology oriented. Clear, right? Course offers you flexibility. As I said, you join any course, you can switch to any other domain in 2 months. You won't miss the topics. You may say, will I miss that 2 months? No, you will join into the next batch. Only 1 month you will miss, so you join into the next batch. No additional fee, no need to repeat entire 2 months. You only miss 1 month, so that 1 month you join into the next batch. Next, preparing for job. Okay, let me tell you one thing. See, in all this market, right, AI market, with all this, you need to be very focused. You need to be very passionate about what you are going to learn. Okay, just just attending the training, just taking the training doesn't guarantee your job. Whatever you do, you need to learn with passion. It doesn't mean that you have to spend 16 hours 15 hours a day. No need. No need also. Every day quality 8 hours. Every day if you spend quality 8 hours, 6-7 months, that's all. 6-7 months, every day you write down, am I spending 8 hours? You write down, and you write down a notes. Today how much time I spend? That 1 hour, I mean quality hours means what? No other focus, only whatever you're studying. Let's say I'm doing assignment. In that 1 hour I should only be doing assignment. I should not be looking at WhatsApp, Facebook, what is happening, what is WhatsApp status of my friends. Nothing. You should be only focused on that. Like that you spend 8 hours. Remaining hours you do anything. You look into status, you look into WhatsApp, anything, doesn't matter. Like that if you do 7-8 months, 7 months, you will be able to get a job. There's a very good chance that you'll get a job, because I cannot say 100% guarantee. There's always a market requirements keep fluctuating. uh, the when you are going to get job also depends upon what is your current preparation level. Let's say during your BTech you didn't learn much. Not your fault. Sometimes your college may not have offered you the right platform, right faculty. If you have to start everything from scratch, then you will have to spend more time. So you have to, from our side, we'll provide support for every category of people. We'll not say we'll identify top 30% or 20% will only support that. No, every person will get the support. Only thing is that level of support. Let's say someone is not able to cope up with Verilog and they need support. We'll ask him to repeat the course. So we'll do the thing in such a way that it will be benefit. It will be in your benefit only. We may even ask you to repeat. Even repetition, no cost anything. But we should ensure. We will ensure that we will identify your strength, weakness, your preparation level, and accordingly suggest you what you should do. All that. Okay. But from your side, you join this course only if you can prepare with that passion. Okay. In any job market, there will be jobs always. Only the skill set is what is important. If someone is not able to get a job, if the person don't have the right skill set, companies don't hire, because companies, even right, money has a lot of value in the life, today's life. I mean, I'm not telling my personal perspective, but the society, everything, money has a value. When a company pays some money, they expect you to do something productive. You just sitting and going and not doing anything, nobody pays you, right? Even in the house also, your family, that's how a lot of relations work at some or other point of time, right? So companies want you to be productive. I mean, they don't want you to build the entire company. Whatever work given to you, will you be able to do? This training is designed in such a way to prepare you for that thing. Whatever you couldn't learn properly during your BTech time, you may have learned. I'm not telling nothing, because I cannot underestimate colleges are bad or anything. We will customize the thing in such a way that you are exactly prepared for the job, but from your side you have to give that minimum commitment. 8 hours I'm going to spend, and not everything is going to be very easy. If everything is easy, no need to come here, right? You can prepare yourself itself. There are some difficult parts. Two things: one is discourage, you don't even do anything, you don't come to us. Second is what? You come to the trainer, you come to the admin staff, you take support from the team, and you ask them to schedule a support session, doubt clarification session. You get that support. Okay, you have to become that proactive. You have to become proactive, you have to actively participate in the discussions, you have to actively take advantage of the trainers course, everything. That attitude you have to develop. Understand that? As you should not be introvert. See, as an introvert means what? Just keeping it to yourself, not talking any, not explain, I mean not discussing anything with other trainers or other friends. That won't work. You have to be open, you have to take advantage of the course material, trainers, facilities provided, everything. Okay, that is where you are going to benefit out of the course. Okay. We do track your performance. I mean, I won't go deep into it. I mean, we'll be making you see many times what happens. uh, when you go for a job, you're expected to be proficient, good with English communication skills, how you explain the things. During your college, based on which college you are from, you may not be proficient, because what happens, let's say you're from some place in Andhra, the faculty might teach lot of things in Telugu. Communication might itself happen in Telugu, and you don't talk in English, so you won't be familiar with how to communicate all that, right? So our training will also involve soft skill training, where the trainer will help you learn some amount of English grammar, how to present, how to explain the things. So that will be there on a weekly basis. Every week soft skill training will be there. Okay, it's just that you have to utilize. Say, we cannot, can our trainer teach all 6 days English only? All right, in a week, 2 hours. During the 2 hours, they will give you activity. They will ask you to come up with a simple uh, explanation about your experience. You should do that actively. Whatever trainer does, they will do for a reason, right? Gradually, when you do that, by 6-7 months, you will see that improvement. Okay, this is mostly, that soft skill training is mostly designed for, I mean meant for people who come from non-metro background. Okay, you should understand that people who are doing engineering in who have done their whole education in Bangalore, let's say, people who are coming from non-metros, there's a gap actually. We have to agree, we have to accept that fact. We have to accept that fact. What is that we have to accept? People who have already done their BTech in college, schooling, college, all that in Bangalore or Hyderabad, they will have advantage over people who are coming from non-metros. So you have to fill that gap by putting more effort in a systematic manner. So our training is not just for technical purpose. Our training will try to fulfill that gap. But as a student, you should be willing to take that support. You should be willing to take that support. Okay, uh, that's the only thing. I don't want to give too much lecture. I'm telling that you should be willing to learn. You should have that willingness that I should become very good at communication. I mean, when I talk, people should listen the way I'm telling, way I'm talking. People should understand. That passion you should develop. You understand, right? Everything should be driven by a passion to learn, passion to excel. Okay. We will also track your attendance. We'll make sure that you do, I mean, to improve those skills, right? We'll make you do the presentation. Many times what happens, there are 30 people batch, we schedule a presentation. What is presentation is, we give you 2 days time, come up with a simple presentation, 10 slides. The way I presented, you have to come and present. Out of 30, 25 people won't even come and present. Out of 30, 25 will be absent or 20 will be absent. Then when will they improve their skills? I mean, idea is what? To make sure that you present. See, initially, first day when you do, it will be not good. As you do, it keeps improving. So that is how it has been designed. You have to take advantage of whatever schedule has been planned for you. There will be mock interviews will be there every month for every topic. Evaluation test will be there. See, some evaluation test you may not score well. Let's say out of 100 you may score 50. You have to ask, why, where did I lose 50 marks? What is that I could have done to improvise? So you need support with that 50 lost mark. You can talk to that trainer and schedule a session to clarify all those things. Let's say you feel, no, I'm not good with Verilog, I'm not good with system Verilog, I want to repeat. We'll give you option to do that. Okay, your training should not be driven by duration, like I have to do everything, get a job in 6 months. It should be driven by passion to excel in the subject. You should think that, when will I become expert in digital design? And like any question you give me in digital design, I'll do it. Any kind of requirement you give me in Verilog, I'll do it. Any kind of system Verilog requirement you give me, I'll do it. That passion, that direction you should give to your preparation. Then automatically you will see that you will get a job. Okay, though it may look very generic knowledge, but that's a fact, right? I have to, as a teacher, I have to tell you what should be your purpose of training. Purpose of your learning should be to excel in the specific subject, then you automatically get the job. Okay. And we will create one dedicated WhatsApp group for every student. Some of you might have already enrolled, might have one WhatsApp group. You have to use that group whenever you need a support. It could be as simple as that, I didn't get the course material, I need a support session today, I need a mock interview. That is a group where you can connect with our team and get the support. Okay. What is the one baseline you have to remember throughout this training? You have to ask for any support you need. You have to proactively ask. Let's say placement, you have to ask, when will I get placement support? That proactiveness I want you to develop and get the support. Okay. So what is the final goal of 8 months of training? Tell me. Students should be enabled to work in the job independently. When you go to a job, let's say tomorrow you are hired in Qualcomm, let's say, there you should do the work without any support from your seniors. They give you some work, they won't give you some complex research work or development work. They'll give you simple work. Are you able to understand that work? Are you able to implement that requirement? That should be the thing. Our training is modeled in such a way that it helps you reach that stage. It is a collective effort. It's not institute alone work. It's not alone student. Both together, we will make it happen. Okay. So what are the course prerequisites? You should be good with quantitative aptitude, basic logical reasoning, right? Your IQ level should be at minimum. If it is too poor, you cannot do anything. Someone don't have basic IQ level, basic logical reasoning, we cannot do anything. You should be practicing some amount of that. Students should have ability to understand the problem, because what logical reasoning will give you? Ability to understand the problem, ability to come up with a simple logical solution. Should be able to do logical analysis. Okay. Other than that, you should have willingness to learn. Two things: quantity, aptitude and attitude. Attitude is what? That positive attitude, that what is that I'm going to learn today? How can I become expert in this subject? That should drive your whole preparation. Okay. Yeah, that's I think that much. What talking about skill set, whatever is required, everything will be taught from the basics, starting from digital design. We'll start from the basics like what is logic gate, what is radix formats, what is truth table, everything will be taught. Only thing is, only difference how it is going to differ from your college btech college life is in btech semesters. What happens before semester exam, if you spend 1 2 weeks, you can prepare entire thing and you can still score 70 to 80%. It is quite possible because there what happens is you have a list of questions, list of topics. If you prepare, similar questions might come. Here it is not going to be like that. Your focus has to be for entire 6 to 8 months time. Most of the people lose there. Actually they are not used to that. For example, if you ask me, I can sit 1 year and I can prepare every day 8 hours. I'm not telling is it smartness. No, somewhere I have passion. I mean, somewhere my childhood has been such that it tells me you okay, you have seen the lot of hard things, so it's okay to spend time, spend 8 hours a day. You have a keep a specific goal and prepare for that goal. So that should drive. So that is where significantly differs. In btech you are not used to that at all. Not used to spending 7 8 hours every day. You are mostly used to preparing before the exams. That attitude will never work here. If that is the approach you are going to follow, you should not do training at all. That is the approach you are going to follow with, you should never join any training, because it's not going to work for you in this competitive, it's highly competitive market right now. You have to be focused every day. That focus will come only with passion, that I should become expert in the verification domain. That's your baseline. Yeah, that's all. And now if we have any questions, we can answer those questions and then we'll end. Those attending online, please post your questions in the chat window. A fee structure, please connect with our team. One more thing, one more update we want to share is we have now all the three tools. Like there are three major companies are there: mentor graphics, sorry, synopsys, cadence and mentor graphics. So we have all the three tools. At some point you will get exposure to all the three tools. Majorly our training will be driven by synopsys tool and mentor tools, but at some point we'll give you exposure to cadence tools also. Fee structure, Raja, I will please connect with our team. Yeah, okay. Placements, see what happens for placement is we will provide you 100% placement support till you get a job. I mean, we cannot time your job. We cannot tell that this month you will get job, next month you will get job. The support will be there till the time you get a job. We are connected with lot of companies, I would say 100 plus companies. So we keep regularly keep checking with those companies whenever they have requirements. Sometimes they themselves inform us many times and we keep checking with them. So we maintain one individual WhatsApp group where we keep posting the job requirements. In that group only our students will be there who have completed the training. So there you have to apply for that job and your profile will be shared with the company. Before that we do some simple mock interview for you just to ensure that your preparation is fine. Then we coordinate the entire process till the time your resume is shortlisted, till the time your interviews are done and you get the offer. We coordinate the entire process. So that support will be there throughout the course. See, many institutes I have known, they will tell, they will give only 6 opportunities. Support will be there for 6 months. That will not be the case in our institute. You will get as many opportunities as you want. First thing, support will not be for limited duration like 6 months or 9 months. Till the time you get a job, you'll get placement support. And even the technical support will be there till the time you get a job, because many times what happens after 6 months you forget the subject. Will help you continue preparation. And we had good placements. I mean, there were multiple companies which have hired in recent times: HCL, True Chip, there are Juntron Technologies. There were other companies which have hired from us in the verification domain itself. Okay, so there are few product companies have been hiring, and mostly hiring is into services companies. Yeah. Any other questions? See how it works is, question is what, once we get placed, once we get the job, can we attend other interviews, or is it the final one till we get placed? Once we get placed, see, you can attend product companies. See, once you, let's say, get into services company, no option to attend other service company. But if a product company comes, we'll give you option to join, attend that product company. Let's say tomorrow Intel comes, okay, you already got placed and working, we'll still consider your profile for Intel, but not for some other service company. Any other questions? Those attending online, you have any questions?
Hello, sir.
Yeah,
Sir, good afternoon. Sunita here.
yeah, please ask.
Sir, like as you said, like 8 hours if we spend dedicatedly for the course.
Yeah,
Yeah, and if we are like, yeah, like everything evaluation depends on like how much we have learned and whether we are doing perfect or not. And if suppose if we are on the perfect track,
yeah,
clearing all the assignments, what are the projects, then the course time can be like, reduced also. Not even, as you said, like 8 months it will be, where in which 5.5 months, like, dedicated course.
yeah.
Suppose if you are dedicatedly putting up our efforts in this learning and all, so the course duration also may reduce, right?
No, no, duration will remain same. But if you are going for a self-paced learning course, what you are telling is correct. In
Okay, sir.
self-paced
Okay,
learning
sir.
course, you get access to all the recorded videos, which you can
Mm-hmm.
complete anytime as per your convenience. When it comes to live training, we have to follow the same schedule, right?
Okay, yes, 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 sir. Yes, sir.
Yeah.
Done, sir. Thank you so much.
Thank you. So if you, I mean, let's say you are, you are not working, you have a lot free time, and you feel you want to finish the course quickly, you can go for self-paced learning. Even in that, I have a suggestion. You can start with self-paced learning. You can try for initial
Okay.
2 to 3 months. If you are okay
Okay,
with
sir.
self-paced, your own pace of learning, fine. Otherwise, we'll give you option to switch to live training.
Yeah, yeah, yeah. Anyway, whatever the self-paced, we have to be taking the live training also, sir, which is very important either.
Yeah, yeah, yeah. See,
Right.
as I said,
Right, sir.
right? See, to get a job, you don't need to wait for 8 months. Your
Okay,
placement
sir. Yeah.
support will start as early as sixth month itself.
It all depends on how much effort we are putting on the course and how much we are clearing the projects and all. Right, sir?
Exactly, exactly. Yeah.
Done, done, done. Thank you
I'll
so
tell
much,
you
sir.
only one statement. Give you one statement. See, we have one
Yes.
project, final project called as Ethernet MAC functional verification. If you do that project completely, we can give
Okay, sir.
you 99% job guarantee. One final project will
Sure,
be
sir.
there. Okay,
Okay.
that if you can do yourself, I mean, I will be teaching actually. You just have to follow
Okay.
the instructions that are provided by me or other trainer and do the project
Mm.
yourself. 99% you
Okay.
can be assured that you will have a
Mm.
job.
Because what I am planning is that, sir, like, I don't know whether we can discuss here or separately we can discuss.
Maybe you can call me or my
Sure.
number. I'll give you my number. You can even call me if you want to.
Yeah, sure, sir. Please, sir. It will be helpful. Thank you so much, sir.
Yeah. Any other questions?
Yeah, no, sir. Thank you so much, sir. Really, the session is very helpful because we are having the zero knowledge, like what is what the course we are taking, how much we can do, like what's the phase of learning. This training session really helped us.
Okay, sure. Thank you for
This
that.
demo session really helped us. Thank you so much, sir.
Any other questions? So if you don't have any other questions, we'll end the session, and the course will commence from Monday onwards. My suggestion is, in case you have already decided to take the course, so don't delay the enrollment. But if you need time, let's say 1 week, 2 weeks time to make decision, then you can hold. But if you have decided, don't delay, because what happens, every 1 or 2 sessions you miss some topics. Then catching up, let's say you didn't attend today's session, tomorrow's session you won't understand the context, because my tomorrow session will start assuming that you have attended today's session. So please don't delay. And okay, thank you so much for all the feedback. You can always connect with our team for any further clarification. Okay, we'll end the session here. Yeah.
Those are career gap. It is effective.
Thank you, sir.
Those with career gap,
Yeah, career gap means someone working with another means
uh, I'll tell you one thing. See, regarding career gap, what happens is these days companies are preferring hiring people with education gap, career gap. What companies will do is they will hire you. Let's say you are 2021 pass out. Some not product companies, some smaller services companies will hire your profile. Whatever 3 4 years gap you have, right? They will train you additionally. They will show your education gap as company internal experience. Let's say some XYZ company you have. That XYZ company will hire you. They will show that you have worked in their company for 2 years as a VLSI engineer only. That's how the business works. It's money, right? So a lot of things happen around that.
it's like third party.
Not that, but proper company only hire you. They will show yourself as a not as a fresher. They will show your profile as a experienced person.
It is not effective that is high.
No, no, no. They will more readily hire you. That's what I'm telling. Because it's more easy to place a person with the 2 3 years gap.
No, I'm working in some another domain.
That's what they won't bother. See, it's all comes down to your knowledge. If you are very good with the subject, will they bother about what you did other day? See, let's say I want some resource for my institute. Will I bother about what he did earlier? As long as he knows what he can do, whatever my work is there, that's sufficient. My just to give in summary, even if you have education gap,
Not education.
no, no, no. Let me tell you. If you are from a different working domain, it won't impact. Okay. Only final in all the cases, final thing is what? How good is your preparation? If you are good and you do well in the interview, there won't be any problem. There are many people who are able to switch the domain. But only challenge you will face, I'll tell you. Since you are already working in some other company, you'll have to spend at least 40 45 hours there minimum a week. So you have to take out time for this one. That's the only challenge you are going to face. Otherwise, opportunities won't be a challenge for you. Challenge will be taking out time and preparing is the challenge.
Oh, I will already resign.
Oh, if that is the case, then it's fine. Then there won't be a problem. It won't be a problem. I mean, you can go by my word. There are many cases where people were able to switch the domains. Okay. Thank you.